We're going to finish up this section with a couple more applications. This is probably the hardest problem in the whole semester. I'm just going to warn you guys, we're basically going to be filling a page with algebra in both the problems we're doing today. I'm sorry that it's just that's the way math goes after a certain extent. It's about putting down your thoughts on paper, and sometimes your thoughts have to last more than a minute. It's just the nature of doing it. This is actually made a lot harder by the notation they are using here. So I'm going to actually look at the problem in the book real fast and give you guys a comparison. In the book, if we look at that problem, it is this one. It says, an equilateral triangle is inscribed in a circle of radius r. See the figure. Express the circumference of the circle as a function of the side length of a side of the triangle. It says first to show that r squared equals x squared over 3. This is a very important equation. It really helps in the problem. So I'm going to stop here for a second and show that. So if you look at the equilateral triangle, I'm just going to bring this up. If we have an equilateral triangle, x, 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 and we know this is r. Well, how do we find the relationship between x and r? Well, let's actually draw the rest of the distance here and call that d. Or in fact, let me actually just do this. It's a little bit simpler. So I'm going to draw it bigger. So we have the center of the circle goes up here, r, and I'm going to call this distance d. Alright, well, we know this is x, this is x, this is x. And we know the area of the triangle. Well, we know a couple things. We know 1/2 of x plus squared plus r plus d squared equals x squared. And I also know 1/4 x squared plus r plus d squared equal x squared. So move that over, you get r plus d squared equal 3/4 x squared. Square root both sides, r plus d equals, let's see, that is square root of 3 over 2x. So d is square root of 3 over 2x minus r. And I also know I can draw these triangles, which you note that height is d. So I know that this is r, that's d, that's 1/2 x. I also know 1/2 x squared plus d squared equals r squared. In fact, this is much easier to work with. So d squared equals r squared minus 1/4 x squared. So d is the square root of r squared minus 1/4 x squared. So we plug this in here. Square root of r squared minus 1/4 x squared equals square root of 3 over 2 x minus r. Square both sides, r squared minus 1/4 x squared equals 3 over 4 x squared minus, let's see, 2 times square root of 3 over 2 times r, so square root of 3 over 2 xr, and then plus, oh, plus, that'd actually be a positive 2. Well, just do it like this. It's going to reduce. Plus r squared. The r squareds will go away. Move the 3/4 over. You get a negative x squared. Because negative 1/4 minus 3/4 is minus 4/4, which is negative 1. And we get a negative square root of 3 xr. Divide out the x, divide out the square root of 3. R equals x over square root 3. And I believe, yeah, that's basically the same instruction. R squared is x squared over 3, so r equals x over square root 3. Alright, but that's very important because it means, that the radius of the circle equals the side length of the triangle squared. The radius of the circle squared equals the side length of the triangle squared divided by 3. So let's do the problem from the exercise set. Alright, notice in the diagram here they have 9x and they have 4r. That is just screwing with our brains because this is the radius. 4r is the radius. Normally we would just label it r, but it's 4r here. Side of the triangle is 9x. So using the exact same rules, we know that 4r squared equals 9x squared divided by 3. And that means we're going to get 81x squared over 3, which is 27x squared. And that's just a bit screwed up, but it's what we got. So then, express the area within the circle but outside the triangle. Alright, area of the triangle. Well, easy enough to do. Just find the height by doing the Pythagorean theorem. H squared plus 9 over 2x squared equal 9x squared. So that's h squared plus 81 over 4x squared equals 81x squared. Subtract that over. 3 times 81 is 243, so that's 243 over 4x squared equals h squared. So h would be square root of 243 over 2x. Or reducing that, I believe that will be 9 root 3 over 2x. Because 243 is 3 and 81, and square root of 81 is 9. So 3 squared, yeah, square root of 3. Alright. And so the area of the triangle is 1/2 times 9x base times height, which is 9 square root of 3 over 2x. So that is 9 times 9 is 81 square root of 3 over 4 x squared. Then area of the circle is pi times the radius squared, and remember in this case the radius is 4r. Still screws with me. So that's 16 pi r squared. So that's the area of the circle. Area of the shaded region, then, is 16 pi r squared, which, by the way, oh, they want it just in terms of x, my bad. So there's no real reason for them to multiply this out. We know 4r squared is 27x squared, so it's pi times 27x squared, so 27 pi x squared. So then, area of the shaded region is 27 pi x squared minus 81 square root of 3 over 4 x squared. And there we go. Probably the hardest problem in the semester. It's not for the faint of heart, but we got it done. And we could do lots of other problems, but I think that's actually where we're going to stop today. The next time we'll actually start up with the next chapter. We'll start talking about linear functions. Now that we're done with introducing functions, we're going to talk about classes of functions. So in chapter 4, we'll talk about linear functions and quadratic functions. In chapter 5, we'll talk about polynomial functions. And in chapter 6, we'll talk about exponential and logarithmic functions. Have a great day.